Okay. So, all right. So we are meeting here to discuss Hive today. Okay. So what you guys have gone through as far as HDFS, MapReduce, HBase, I would say, not so much as Plume. Hive kind of builds on top of it. Okay. So Hive, is basically nothing but a SQL engine, thrown on top of Hadoop. That's as simple as definition for Hive, right? So the question which comes to mind is, what is the problem we are trying to solve here? Of course, we are collecting more and more data in HDFS. And there's a lot of data which is being collected in HDFS. And this data is then available via MapReduce for any kind of processing which can be performed on this data which is residing in HDFS. But as we went into MapReduce, we found that MapReduce is firstly a programmatic model. Number one is that the first problem we were exposed to was that MapReduce is programmatic in nature, which kind of rules out a lot of people from the community who don't have a programming background. So if you're not a Java background guy or a Python, Ruby, Perl, Scala, if you're not from that background, even C, C++, if you're not from that background, you pretty much are handicapped to use a system such as Hadoop. Now, you know that in the community, that is a big handicap, meaning only about 10% of the whole community would know that. So what do the 90% of the people do? Meaning, what do all those analysts do? What do all those BI guys do? Business intelligence guys do? What do the ETL guys do? They don't have any clue about programming. All they have been working with is tools and SQL, and they've been getting by very easily. They were focused on delivering value to business problems by use of SQL. So that is where Hive comes in. What Hive does is, Hive is basically a compiler. What this compiler does is it takes a given SQL statement. You know, what is SQL? SQL is structured query language. So what is happening in SQL is you really have a tuple theory, and that tuple theory basically says you have table A, table B, and these two tables have got something called a relationship with each other. The relationship can be one-to-one, one-to-many, many-to-one, many-to-many. There are some constraints which are imposed where, you know, there are transitive constraints, there are other constraints, foreign relationship constraints which are imposed between table and table B, table A and table B. So this table thing, you know, is pretty much is a very good construct to work with. Analysts have grown into that whole space because of their familiarity with SQL. So what Hive is trying to do is, Hive is trying to impose a SQL-like construct on top of MapReduce, not on HDFS, on MapReduce. So what basically Hive does is it produces compiled MapReduce jobs, both with, you know, the mapper and the reducer tasks, to achieve what MapReduce can do. So essentially, you're still sticking to the MapReduce paradigm. You are running MapReduce jobs, possibly written in Java, for queries which have been written in SQL. So Hive acts as that engine which translates a given SQL into a given MapReduce job in Java. Of course, this has some costs. Costs are, you don't have so much of fine-grained control over joining of data sets, etc. That's number one. What Hive is doing is that's number one, that it converts a SQL statement into the corresponding Java program. The second thing Hive does for you is it creates and collects, and imposes a tabular view on your raw data, right? So your data may reside in HBase, your data may reside in flat files, your data may also reside in XML. Hive gives you that ability to impose a tabular view, as we are familiar with tables in SQL, in relational databases. It gives you a tabular view of that data at read time or write time, whatever. The data in its natural format, whatever that is, whether it's flat file or it is hello?
I think we lost Preetpal. Hey, Preetpal, are you there?
Preetpal?
Let me know.
Okay, so how long have I been speaking on mute?
Maybe 2 minutes.
So, wow. So, what part did you miss? I was man, I spoke at length about Hive and SQL and all that. So, what part did you miss? Did you miss the whole part?
No. Well, you were talking about the files and making Hive giving a tabular view.
Right. So the first thing Hive does is Hive acts as a compiler. The job of this compiler is to convert SQL programs into MapReduce jobs. It's the whole thing. I mean, I'm pretty sure you worked with a leading database like Oracle, DB2, SQL, Server, MySQL. All of them have this explain plan construct, which basically is a SQL engine, and the SQL engine is spitting out a explain plan, which results in a program being executed behind the scene on your data, which is being stored in a proprietary fashion. That's how the relational databases work. What Hive is doing is essentially it's doing a similar thing where it's taking a SQL and converting it into MapReduce jobs. And those MapReduce jobs are then scheduled on your cluster. That's what it is. After it has been converted into MapReduce jobs, those MapReduce jobs can do anything, like we have learned in our MapReduce session. The second thing Hive does is it provides, because of this semantic ability, it allows you to plug in. I mean, because it imposes a tabular view on your data, because it says, the logical view of your data is a table, the data can be stored in many different formats. What are those formats? The first format is a flat file. The second format can be an HBase table. The third format can be a Cassandra table, so on and so forth.
Okay.
Yeah, I'm here. Give me 1 second. So Hive lets you have these raw data representations, which may be actually in anything. It can be in a flat file, XML, JSON, anything, HBase, whatever. So Hive, the second part, remember, all the connections are happening. You guys are with me, right?
Yes.
So all the connections or all the processing is happening through MapReduce. Okay? There are no two doubts about it. All the processing is happening through MapReduce. But Hive provides you a rich set of APIs or libraries, for lack of better words, programs written in Java, which can allow your MapReduce programs to talk to any of these systems which I just described. Okay? The only thing is that the catalog meaning the information about what is the description of your flat file, what is the HBase table, how am I supposed to identify columns from this flat file, or how am I going to identify columns from an HBase table, or how do I identify a row. All of that is that functionality is provided through a function, but the cataloging of that information, that what column maps to what attribute of the file or whatever, that is stored in a metadata database, right? Which we normally refer to as the meta store. So in that meta store, you store the information about information. So it's the descriptive information about what's in your flat file or what is in your XML document or the XML this thing. There is this construct called SERDES, serializers and deserializers. We call it SERDES, SERDE. They are responsible for conversion of data back and forth between the raw native representation and a tabular representation and a tabular to the raw native representation.
Okay.
So SERDES are what Hive plugs into your MapReduce programs for the MapReduce program to read data from the corresponding input or output. So think of SERDES more like as input formats and output formats. Remember input formats and output formats from MapReduce?
Yes.
So at MapReduce time, you ask this question as to what role does input format and output format perform, and why are they separate from the map function and the reduce function? This is the answer. Because you have separated them, because you have separated this from the actual mapper or reducer task, this guy can be involved in interpreting or doing how the data needs to be read and what format it needs to be read from. That's why input and output formats are like that. So SERDES are that in case of Hive. Okay? So just a summary again. The summary is Hive is a SQL construct imposed on top of your Hadoop ecosystem. That ecosystem can contain data stored in HDFS, in HBase, whatever. Hive provides you the tabular view of your data. Hive allows you to interface with any format of data, meaning data stored in any format. Okay?
Okay.
That is what Hive is. And the job which Hive performs for you is very powerful, that it lets you mainstream Hadoop to non-developer community, number one. And number two, it speeds up your development time. So think of, writing a MapReduce job versus writing a Hive SQL script. Okay?
Okay.
So what is Hive? A system for managing and querying unstructured data as if it was structured. Uses MapReduce for execution, HDFS for storage. That is not an entirely true statement. It can actually interface with many other things. Key building principles. You have SQL. It provides you that extensibility, meaning you can plug in MapReduce scripts. You can write your own reduce functions, map functions, call them as functions, and these functions become callable. And it allows interoperability, and definitely the principles of performance are also there. whatever holds true for MapReduce holds true for Hive also. Just remember that.
Okay.
Any questions?
No.
So if you are a champion in SQL, you're a champion in Hive. That's essentially the story. Meaning, for now, if you want to be conversant with Hive, all you need to know is SQL, and you should be able to be proficient on Hive. Okay. So what are the, just like you would have an Oracle or SQL Server or whatever, what are the different data types in Hive, right? So you have the primitive types, tiny, small, tiny int, small int, big int. Can anybody explain what would that mean? Tiny int, small int, big int?
Small int is short.
Yeah, I mean,
Probably int is int and big int is probably long.
yeah, remember each of these map into one of your writable things. Long writable, int writable, short writable. But essentially the job of these writables, this is to capture integers. Similarly, you have booleans, you have floating point numbers, you have string. Then you have complex types, right? You have structs, maps, and arrays. Okay? So it's a pretty rich construct. Can anybody visualize where I will be using maps and structs and arrays? I mean, let's be more specific, maps.
Maybe on HBase.
Wonderful. On HBase, you can use that. Say, for example, you have an XML schema behind, XML documents behind this same tabular view. So XML has like a group defined with occurrence more than one. You can use a structure or a map for that.
No, I did not understand. Can you repeat it?
So think about this, that on HDFS, you are storing XML documents, correct? Right? In HDFS, when you are storing XMLs, some of your XMLs may actually have that array construct with occurrence greater than 0. So you have multiple, what do you call it? I'm forgetting the name. Multiple nodes of the same type in the XML document. So if you wanted to have a collection of those elements in XML, with each element being a sequence of other elements, you can use a map for that.
Okay.
Make sense? Another place you can use it is JSON. So you can do the same thing with JSON also.
And then what is struct?
Struct is a struct, meaning think about a complex type in XML, right? What is a complex type in XML?
Custom type.
Huh?
Any.
So let's say you're storing data like this. You have person, name, age, sex, and class, and grade, right? Name is A, close. Age is 21, close. Sex is male, close. Class is 10th grade, close. Gender is, what is this? Grade is F, close, right? So this is a person, it's a complex type person with these as elements of that, right? So if you wanted a construct for this person, you could have said it would be a struct with this being name and it is of type string, age type int, big int or small int, whatever that is. Sex is, Boolean, let's say true or false, etc. Make sense?
Okay.
And that's what struct is. Struct is basically, if you want to map a complex type, then you can use a struct for that.
Okay. We can
So this construct,
in this case.
is anybody asking me a question?
Yes. What I asked is like, can we not use map as well here? In this particular scenario.
Yeah, you could have used a map, right? But you would have used a map of, you would have to use a map of maps. Or you could have used a map of structs.
Okay, yeah, I got it.
Any other questions? Praveen, Jaya, are you okay?
Yeah.
Sorry, Praveen left. Okay. So, tables are analogous to tables in relational database. Each table has corresponding directory in HDFS. This statement is not entirely true. Like in the case of HBase, using a SERD, you're directly going to HBase to grab data out of that table. But for most parts, this statement is true, that each table has corresponding directory in HDFS. So if you have a directory named ABC and you call it table as person table, it's basically going to impose this and store this relationship in a meta store. Make sense? Now example is a page view table, PVS, and it maps to a directory called warehouse PVS. So in the table world, there comes two terms. We will discuss that at length later on. There are two types of tables, which are Hive managed table and external managed table. External managed table, an example of an external managed table is a HBase table, or a table which is not managed, or the data for that table is not stored under the default Hive directory. What is the Hive directory? Hive directory is a directory assigned on HDFS. Typically it is user Hive. It's under user Hive. If the data is stored under user Hive, it's telling Hive that you are the sole guy who's responsible for their data. So implication, there's not much implication between externally managed tables and Hive managed tables, except that when you say truncate or delete, it doesn't work for external managed table, it only works for Hive managed table.
Okay.
So, if you notice, the create table T1, DS, country float, li list, map of string, comma struct, P1 and P2. With this construct, Hive provides you a very rich set of representing your data. So if you notice with the country or DS, you are able to represent your data in a tabular fashion, but with map and struct, you are able to also patch the unstructured part of your unstructured part of your of your data, the unstructured nature of your data, which cannot fit directly into a relational model. Make sense?
Yes.
Now, I have introduced the concept of tables. Now I'll introduce the concept of partitions. Just like in any big table, you have this concept of partitions, and there are partitions on that table, which allows you to do the following. Number one, it allows you to manage your data in a more manageable fashion. I'll give you an example. Let's say you have 1 trillion records and a 100 gig table in Oracle. Typically, when you talk to the DBA, they say performance is running slow, indexes are being updated slowly, etc., etc. They say, is there a way to partition this table by range or something so that, these partitions almost act as mini tables from a storage perspective, but logically you're still looking at the same table. What it does is, by way of doing that, it reduces the complexity, it reduces the volume of data which needs to be maintained per data structure. Per data structure meaning now you have local indexes, and local indexes is what you're trying to maintain rather than a global one for the whole table. So it reduces the cost of maintenance on a table and all that. Secondly, when you're trying to query, if you say, if let's say the table is partitioned by a range of numbers, if you query by that range, it effectively negates those partitions or use of access of those partitions which do not have that number. So by this way you're doing something called partition pruning at the time of calling of SQLs. So similar construct exists in Hive also. The only difference is it is implemented by way of subdirectories of directories. I already said directories are tables. If you have a directory and it has subdirectories, then you can have named partitions by having subdirectories named like that. So if you notice here, DS equal to 2012-0410, that is a partition in that table. Okay?
Okay.
Now, Hive query language. So Hive query language is what we call it as the SQL for Hive. These are different commands: create table, test part, DS, HR, partition by this, insert, overwrite into table, test part, partition this, select star from T, alter table, test part, add partition this. Now, I'm going to ask you a question here. You see the second query? What kind of MapReduce job will run for this?
Map.
Huh?
Map job.
Sorry.
I'm just taking this map job.
Yeah, meaning because you don't have any grouping or anything like that, it will be your map only job because you're just taking data from one and moving to another, right? Right? So again, partitioning, select star from test underscore part where ds equal to this. Will only scan all the files within test part ds 2009-01-01 directory. So it essentially negates the use of the other directories. Make sense? Does this make sense?
Yes.
That's that whole partition pruning concept again applied here. Now buckets are almost like they are almost like partitions, but here it's more like a hash partition. Right? Again, this is also for performance gains. So you do a hash partition and then you hash it up and you distribute it equally between multiple partitions, right? Now, the problem with range partitioning is that when you do a range partition on a table, the data may get skewed, but if you do a bucket, the data never gets skewed. All the partitions receive the same amount of data or reasonably same amount of data.
Okay. So
now there is this other thing called external table. Where the data is not managed by Hive. And it is pointing to some other directory in HDFS or HBase or whatever. The data is assumed to be Hive compatible. Well, assumption is always the case, whether you like it or not. And the compatibility is through SERDES. Dropping external table drops only the metadata. Create external table, test extern, user my table, my data. So because the location is a non-Hive managed place, therefore this is going to be this. So now your delete, your truncate and all those things don't work. Can you imagine where we would be using external tables besides HBase and those things? Why would you have an external table on HDFS?
Just to have select or join. Just when we need select.
Right. I'll give you a use case. The use case is, typically where you have external tables. Let's say there is a map reduce job or some ETL job which was running, which was doing a change data capture kind of a process, meaning the records were inserted, updated, files were transformed, etc. outside of Hive. Outside of Hive, the data was transformed by other means, by pig scripts or ETL jobs or raw map reduce. Now you want to expose the synthesized result of all that processing by way of by way of SQL. That's where you use external tables. The external tables, rightfully so, they don't perform. They don't allow you to perform deletes or truncates. Well, they allow you to perform, but what does that mean? And when you drop the table, only the metadata is dropped. Okay? Now, serialization and deserialization. I already talked about this concept with you. The job of these modules or programs is to convert what is on disk or what is in HBase into a tabular fashion. Okay? So you can also write your own SERDES. Actually, that's what people end up doing mostly. That they write their own serialization, deserialization classes which interpret the unstructured data into a structured way. All right. By default, all CRDs are located in hive_contrib.jar, but you can spin up your own jar, put it on the class path, and you should be good to go. Right? A CRD implements the CRD interface of Hive. Hive file formats. Hive lets users store different file formats, helps in performance improvements. When somebody says Hive lets you store different file formats, it means out of the box, there are different out of the box, there are different CRDs which are available to handle them. And we have already gone through, why we use sequence files, why we use Avro files, why do we have this file or that file format. And the reason is every use case is unique, and this allows you to not worry so much about all of this. So create table, dest1, key int, value string, stored as input format, sequence file input format, and sequence file output format. So this is how you are able to store different file formats into Hive. All right. So how does the Hive look like? At the end of the day, Hive spits out MapReduce programs, nothing else. Hive spits out MapReduce programs. So the job of Hive is a system which is external to your MapReduce cluster. It is external. All it has are these different components, JDBC, ODBC drivers. Through these JDBC and ODBC drivers, you can connect or you can execute HiveQL scripts or HiveQL queries from a SQL server, from a MicroStrategy server, from a SSRS, MicroStrategy, Tableau, JasperSoft, any of these guys, they can run a HiveQL. And see the power of this thing. The power is now your queries are running on a Hadoop ecosystem of 1,000 nodes, 10,000 nodes by way of just JDBC, ODBC. So the jobs are actually running in the cluster. But Hive is that interface which lets you submit SQL queries over to this place. Second thing is your command line interface. So you are also providing a command line interface. Through this command line interface, you can do interactive queries just like you do it on SQL Server, Oracle, or DB2. They also provide a command line interface for doing all of these things. There's also a web interface for Hive, right? So there is a web interface through which you can do it. By the way, Hive is another library within Hadoop ecosystem. It's basically a web app, and this web app allows you to also submit SQL. So Hive almost acts as a client, a JDBC client to Hive. That's how you should look at Hive. Now, Thrift is that protocol by which you are interacting with the Metastore. Thrift server is through which you interact with the Metaserver. Metaserver is typically a database like MySQL or Postgres or something else. And this guy stores like a column, raw file to column definition mappings, etc., etc. Meaning it stores many things, partitioning schemes, what directories map to what table name, what are the range of directories, and how do they map to a particular table and all that. So this Metastore holds the information about the data, which is then used by Hive to spit out MapReduce program. And then finally there is a compiler, a driver, a compiler, optimizer, and execution. This driver's job is to take the Hive script which has been submitted to it and then turn it around into MapReduce and then submit that MapReduce job onto the cluster. Okay? All right. So this is the overall architecture of Hive for Hive. Alright? This is the overall architecture for Hive. Now, at the end of the day, I keep repeating myself. Hive is doing nothing but submitting MapReduce job to a Hadoop cluster. Metastore, component that stores the system catalog and metadata about tables, columns, partition, etc. stored on a traditional RDBMS. Driver, the component that manages the life cycle of a Hive queue statement as it moves through Hive. The driver also maintains the session handle and any session statistics. Query compiler that compiles HiveQL into directed acyclic graphs of MapReduce tasks. Optimizer consists of chain of transformations such as that the operator DAG resulting from one transformation is passed as input to the next transformation. Performs tasks like column pruning, partition pruning, repartitioning of data, etc. Execution engine, the component that executes the tasks produced by the compiler in proper dependency order. The execution engine interacts with the underlying Hadoop system. So what this basically is saying is, if you have a multiple table join in Hive, which results in a sequence of Hadoop MapReduce jobs to be run. There's no one job, but many jobs to be run. This driver is the coordinator of what runs after what to produce that join. Okay. Swift is a way, it acts as a glue between your whole system. Web interface, web UI, and all that. Hive queries, there are basic SQLs from subclause, from clause subquery, ANSI join, multi-table insert, multi-table, multi-group by sampling, object reversal. Extensibility, you can use pluggable MapReduce scripts, map or reduce, using this function called transform. So using the transform function, you can plug in your own map or reduce function into the whole thing. So Hive is pretty extensible in that sense. You see the power it brings to the table. The only disadvantage is if you have a multi-table join which results in multiple passes over the same data, it can be a killer. That can kill your queries. Right? This is how the join happens. C1.A1 as C1, T2.B1 as C2. That's how you do it. The result of this is a MapReduce job, which basically takes two files and joins and merges them together on this attribute. Even if you are a seasoned MapReduce programmer, if I tell you to write this MapReduce program, you will take a day in coding, testing, all of that. But here you're done in less than 5 minutes. Okay. Insertion, insert, overwrite table, sample 1, directory this, and that. Any questions on this one?
So, what is this insert query doing where it is basically putting sample?
So insert, overwrite, local directory, temp, Hive sample out, select star from sample. Sample is the table name, and you are essentially taking an extract out of Hive and putting it into a local directory. That local directory resides not on HDFS, but wherever the Hive server is running. Okay. So basically, it's basically taking the output out of HDFS and putting it onto your local directory.
Okay.
Local directories wherever you are doing the CLI or wherever you're doing running the SQL command. Make sense?
Yeah. While creating the sample, we can also mention the output format, right? Like if I want to convert like arrow to text.
Right, you can do that. You can do that. So Hive query language MapReduce from map doctext using this particular script as word comma CNT. So you're passing the key value pair here, and the method to use is that function. Now it is using streaming for passing this over, right? From docs cluster by word, reduce word count, word comma count using this. That's how you plug in a map or a reduce function into Hive. From session table, select session ID, this, distribute by session ID, sort by T timestamp. Reduce session ID, TS, stamp, data using session reducer.sh. Okay? That distribute by session ID, sort by timestamp is almost looking like what? Partitioner. That's almost your partitioner from MapReduce. Okay? So, hey guys, I think we should take a hard stop here, and let's pick it up tomorrow. Well, tomorrow is Super Bowl. Do you have any Super Bowl plans?
What?
Huh?